What's up guys, this is CSO, and in this guide I will show you how to create custom target curves for Dirac that can improve channel-to-channel consistency across the entire speaker system. Most people either leave the target curves exactly as Dirac creates them or import one of the generic target curves that everyone else is using. The problem is that speakers don't all measure the same to begin with. Room interaction, listening position, speaker placement, and speaker characteristics all contribute to the final response. When you apply the same target curve to every speaker, those differences won't go away. Each speaker may require a different amount of correction to reach the same final response. This is exactly what this guide is about. I'm going to show you a picture, and if you look at this graph, the light blue line is the original measurement, while the darker blue line shows the predicted response after applying the custom EQ. As you can see, it follows the target curve much more closely. Notice that even after the EQ is applied, the overall response shape is still preserved because we are only using broad EQ filters represented by the dashed yellow line. The goal isn't to force every speaker into a ruler flat response. That would completely defeat the purpose. The goal is simply to make every speaker follow the same target curve as closely as possible. Without this step, some speaker can end up several decibels above or below the desired response, even if they were all using the same exact target curve. By EQing each speaker individually before generating a custom target curve, every speaker ends up much closer to the intended target. These are still ordinary direct target curves. The only difference is that each one is generated from the correction its speaker actually needs rather than applying the same generic target curve to every channel. As a result, the target curves naturally differ from one another while all aiming for the same desired tonal balance. Using Dirac's default sliders may be enough for many people, but they only give you a limited control over the target curve. You are even more limited if you rely on one of the handful of generic target curves available. You are expected to believe that one of those curves is the perfect solution for your system, even though every room, every speaker, and every listener is different. If you want the flexibility to experiment with different amounts of roll-off, different curve shapes, or fine-tune the response to your own preferences, custom target curves gives you that freedom. You can create a couple or as many variations as you like, compare them, and decide which one sounds best in your own room. And here is the beauty of it. You don't have to give up the target curves you already like. Whether it's Harman, Storm Audio, or NAD, this method still works. Instead of applying the target curve directly to every speaker, first you EQ each speaker towards it. And if you're wondering if this works so well, why isn't everyone doing it already? Well, I haven't finished this video yet. Jokes aside, let me show you what this looks like across the entire system. The graph on the top shows what happens when the same target curve is applied to every speaker in Dirac. The graph below shows the result after using this method. As you can see, the responses are grouped much closer together, resulting in a significant better channel-to-channel consistency while still preserving each speaker's overall response shape. I also want to be transparent. Simply level matching the speakers after applying the same target curve already provides a significant improvement on its own. However, if you want to achieve the best possible consistency across all channels, there is more to it than just matching levels. Now let's look at the workflow and see how we got there exactly. First, we measure all of the speakers after the initial Dirac calibration. Next, create your preferred room curve for the mid and high frequencies and import it into REW. We then EQ each speaker above 200 Hz using broad filters to shape its tonal balance. We are not trying to EQ the bass response here. Once the speaker has been EQ'd and bicode filters have been exported, return to the target curve generator. Create a second room curve with your desired bass boost, then combine it with the exported bicode filters to generate the final target curve. The bass boost here is the same as to what the left slider does in Dirac. This preserves the exact tonal balance you created in Room EQ Wizard while allowing you to add your preferred bass house curve separately. It also keeps us out of the frequency range where Dirac ART is performing its own optimization. Because the tonal balance is already built into the exported bicquad filters, you can simply shift the second room curve up or down to adjust the speaker overall SPL while preserving the tonal balance. This makes adjusting locked trim levels quick and easy. Finally, this workflow eliminates the need for separate procedures for bright, neutral, or naturally rolled off speakers. Every speakers follow the exact same process. The only thing that changes is the room curve you choose to EQ toward. Before we get started, here is a quick overview of what we will cover in this guide. We will begin by setting everything up and taking measurements we will need. Then I will show you how to EQ your speakers and how to adjust the target curve depending on whether your speakers measure bright, neutral, or warm. I will also explain the small differences between regular Dirac Live, DLBC, and ART, including what to do when your processor or AVR locks the trim levels after calibration. And yes, for those wondering, this method works with ART. Since we don't EQ below 200 Hz, we leave ART's low frequency optimization untouched. Finally, we will cover a few additional manual tweaks to help you get the most out of your system. I know this is going to be a long video, but I encourage you to watch it all the way through because each chapter builds on the previous one. With that said, let's get started. Now let's talk about what we need. We need a laptop or a computer. We need a calibrated measurement microphone. I use a mini DSP UMIC 1 mic. We need REW, aka Room EQ Wizard, or REW, some people call that. Way to play the OCA sweep files through your AVR, which could be done with PC via HDMI or a media player like NVIDIA Shield Pro. Obviously, we will need Dirac Live, DLBM, DLBC, or ART, and that's pretty much all we need. When it comes to the measurements, pretty much you have two approaches. You can do a single seat calibration where you measure only the MLP, the main listening position, or you can do multi-seat calibration where you measure multiple seating positions and you dB average each speaker. For example, if you have 3 seats, measure every speaker from all 3 listening positions. Then in all SPL windows, select the 3 measurements on the bottom for the same speaker, let's say front left. Then on the top right, you're gonna click on actions, and in that little window that opens up, you're gonna click on average the response. Repeat for every speaker, and at the end you will end up with one EQ bicquad file for each speaker, but each file will represent the average response across all listening positions. You don't need to rerun your Dirac calibration to follow this guide. However, if you decide to do a new calibration anyway, this is the microphone pattern that I recommend. The first measurement should always be taken at the main listening position. After that, the remaining measurements simply sample the listening area. They don't need to match the exact microphone position shown in Dirac. So don't worry about selecting front, back, left, or right. Just keep the measurements within about 8 inches of one another and don't spread them too far apart. For other listening position, just repeat the measurements points 1 and 6. I also made some other videos for Dirac that you can see on my channel. Okay, now that we are truly done with all of this, we can begin. So what we will do first is we're gonna open up Dirac Live. As I said, if you wanna run a new Dirac calibration, you can do that, but you don't have to. All you gotta do is load up your own project that you have done previously, which I'm gonna do. When I done the calibration and I was done with the measurement, this is what I ended up with the filter design. Obviously, if you have DLBC, you can select it here, or ART. I'm not gonna go through how to mess with the support levels, but you're gonna end up with groups, and each speaker pair is in that group. So my front, left, and right is in group 1, then center, surround, subwoofer, and then the heights. Now, what we need to do in order to measure everything so we can EQ is we need to set everything to flat. So you will pull both sliders in the first group to 0, trying to get it perfect if it's possible, which sometimes easier said than done. And then once you're done with that, all you're gonna do is right click, save target curve, and then you're gonna name this flat and save it. Then the next group you can right click, load target curve, and you just keep loading up the same flat target curve for every speaker and subwoofer. For every group, basically, you're gonna load up that flat target curve. So left click on the group to select it, right click, load target curve. If you want, you can save this as a flat project also, but I quickly want to mention about usually how I decide on what bass boost I need, and you can make a note of this, what bass boost would work for the LCR and the surround. Usually I give more boost for the LCR, a little bit less for the surround. I also have people, I also seen people where they like to add the same amount of boost, which could be completely okay and safe as long as you select the right crossover for your speakers. So to be honest with you, Dirac Live sets all my speakers to 70 Hz, which is not entirely correct, especially for my Atmos and surround speakers. I will show you what my surround left response look like, and it's definitely not gonna be okay to leave it at 70 Hz. But so usually what I do is I start pulling up the slider, and I want to make sure that I don't pull it above like the response. So this is on the right side. Actually, you see the spectrum here. I have the measured and the corrected selected. That you want to turn on and see what the measured and corrected spectrum looks like, the response. So basically you don't want to pull it above the speaker's measured response. If there is a little bit of dip, that's okay. But to be honest with you, I'm gonna leave the front left and right probably at 70 Hertz. Maybe I bump it up to 80 Hertz because I can do it manually. The regular Dirac Live does not lock the crossover. So for left and right and the center, I usually go with 6 dB boost. If you click between these two little icons, you can see that it changes between the the target curve points and the sliders. Okay, for the surround left and right, this is, let me just zoom on it right here. The blue one is my left speaker, and as you can see, it doesn't really have much output below 120 Hertz. Dirac Live by default sets it to 3.5, which should be okay as long as I set the crossover to 120 Hertz manually. I did have a instance where I was listening to a movie loud and the left surround speaker was making a bad noise at a scene. So once I once I set the crossover to 120, I rewatched the same scene, there was no noise. So that's what I usually do. Again, you can just adjust this, make a note of it, and just remember where to, what to do when we create our own custom room curves. Okay, the same for the other speakers. Front heights, I would say around 3 dB is completely fine. I will set the crossover for these, all the heights. I set the crossover to 100 Hertz. Even this one I just leave it at 3. It's fine with me, but it's completely up to you how you want to do it. It's just a way, I guess, to check what would probably work for your system. Okay, so you can play around with the slider. Yes, for the heights on the back, even probably 6 dB would work. If I set the crossover to 90 or 100, it would work, but I usually just keep it the same. To be honest with you, the subwoofer and the LFE is 10 dB louder than the speakers, so even if I set this to 3 or 6 dB, I don't hear any differences. The subwoofer will play the bass anyway a lot louder. Also, with the curtains, especially the left curtain, what I need you to pay attention is that for the subwoofer you need to adjust the left curtain in a way that the target doesn't start shooting up to match the measured response, but also you don't want to pull it too much to the left, so the corrected one, it will update in a second, the corrected will jump further lower than the measured one. So you need to adjust the curtain in a way that it doesn't start going up like this, but it's not going further out. So you gotta find a balance. Something like this should work if you wait a second and Dirac updates the filters. As you can see, that should work. Let me see if I put it a little bit lower, if it's gonna get flatter a little bit. Not really. So let's go back just right there. You could see that it was about to go up a little bit there, but this is fine. The speakers, I don't really care about it too much because everything below the crossover will be redirected to the subwoofer. So you know, I don't really care about this if your crossover is set to 80 Hertz, but usually I don't see that issue with anyone. For the speakers, it's usually an issue for the subwoofer. Now, after everything is set to flat, you will go to proceed to filter export. You will click on one of these slots and obviously name it flat, and then you're gonna save it or replace the existing filter, and once you're done you can close that down. Now I'm gonna quickly cover Room EQ Wizard. I'm just gonna explain the most basic things that you need to know to use it for this tutorial. We're gonna go to preferences. Obviously, if you using your laptop connected to the receiver via HDMI, then for the output device you need to select exclusive AV receiver, otherwise you are not gonna see all your channels here. You are not gonna see your heights or front wides. That's one of the reasons we are using the OCA custom sweeps, but you should be able to see your bed layer speakers here. For input, we're gonna select the UMIC 1 mic, and under calibration you have to load up your 90-degree calibration file for the microphone, which should be shown via pink. For the receiver, you don't have to do anything. We can also make sure that the sound setting is correct. The most important thing is that we don't have any spatial sound turned on, so it needs to be off. The default format under advanced should be 48 kilohertz. Okay, levels needs to be at 100 with the balance, everything at 100, and you don't have to mess with the rest. And I think with the microphone it's all, yeah, that is locked. You can change it, but make sure that the audio enhancement is turned off and the exclusive mode is ticked on. Obviously level should be 100, and that's pretty much it. Then in Room EQ Wizard we're gonna use the SPL meter, and very important, the C weighting needs to be turned on and set it to slow. Okay, if the numbers are not moving here, then you're gonna click on this button. If it shows something crazy, I'm talking about like maybe like 10 or 100 or something crazy, try to close down Room EQ Wizard and open up again. With the generator, I'm not really sure if we're gonna use it, but if we are going to use it, we're gonna leave it on noise and pink random. And then the speaker calibration, and we're gonna set the volume to -30 dBFS, and then here you can select a speaker. Okay, if you want a sub calibration, we're gonna select LFE. And then for measurement, again, depending what we measure, for subwoofers usually I go from 0 to 200. For speakers I go to you can do the same thing, 0 to 20,000. This is at -30 dBFS. You can change the length of the sweep over here. Usually I do the 10-second sweep for speakers. We always have to enter the exact name of what we measure. So let's say if we measure the front left, if we are measuring the flat calibration, I would put flat behind it. So you always have to make sure that you name it correctly. Otherwise, if you do a few measurements and you lose track, you have to like start all over again. Okay. You could do measurements from here for some speakers, but as I said, you can't measure the Atmos layer, the heights. So because of that, we're gonna actually click on From File. I'm also gonna link a file below. It's gonna be on my Google document. You're gonna download that, extract that onto the desktop into a separate folder, which is going to have one WAV file, and then all the other speaker files. If you want, you can delete all the speakers that you don't have, let's say FWL and FWR, which will be the front wide left and front wide right. If you don't have front wides, you can just delete that. If you have 0.4 Atmos and you don't have top middles, you can delete the TML, TMR, and just delete the files that you don't need. But when you come back here to able to measure the speakers, you're gonna click on From File here and then open up that 1mm sweep file. Once you're done with that, you're gonna see that it loads this up, and then now we can measure it, but obviously we need to play the file from either the media player or from the computer. Now, two things we need to cover before we start. First of all, we need to adjust the main volume on your receiver or processor, and then you need to make sure that your Dirac calibration is active on that input. So let's say now you're gonna switch over to another input, to auxiliary or to media player. If you switch over, your Dirac calibration might be something else. Whatever you used last time, it might be the one that's still active on that input. So you have to make sure, very important, that you go into the settings and just check on that the room EQ is set to whatever slot that you saved your flat calibration to. Okay. Now, usually the OCA sweep files with normal AVRs needs to be taken at reference level. That means 0 dB. But I have seen some processors like NTEM or RCAM where the volume was only at like 20 or something. And in order to check what works for you, what you can do is measure one speaker, and we're gonna match that with the OCA file. So let me just adjust the volume so it's somewhere else. Let's say I just turned on the AVR, I never adjusted the volume. So what you're gonna do is you're gonna go to the generator, you're gonna select, let's say left or right. Let me select right because I'm sitting between the left and the microphone. So I'm gonna select one speaker, you're gonna set speaker calibration minus 30 dBFS, and you're gonna play that pink random noise. Make sure that the volume is set to AV receiver so it plays through there. Oh, let me change to auxiliary, and obviously now that I just changed the input, I'm gonna make sure that the correct Dirac slot is active, which I had to change from 1 to 3. Now we need the SPL meter, and what you're gonna do is you're gonna adjust the main volume until you see 75 dB on the SPL meter. You don't have to be like extremely perfect. A dB difference is not gonna make a big change. We just need to be at a high enough volume so the microphone can hear the sweep. Okay, so right now I'm actually at minus 2 dB, which is fine. My trim level is probably a little bit too high for the right speaker. As I said, it's fine. So what we can do right now is we're gonna go to the measure, and then we're gonna measure the front right, and we're gonna only measure, we're gonna click on From REW, and we're gonna only measure from 1 to 4000 Hertz. and we can just do a quick one. And yeah, right speaker, let's measure that. Now every time we do a measurement, what we're gonna need to do is we're gonna need to make sure that we are under the all SPL tab, and every time we get a measurement, it's gonna look crazy at the higher frequencies. You can either select a measurement on the left and go to graph and set it to psychoacoustic, or once you have done multiple measurements, again still at the all SPL tab on the top, you're gonna click on actions, you're gonna select psychoacoustic here and apply smoothing. You can go back and forth between whatever you want. Actually, for this one right now, we're gonna select 1 octave smoothing, and we're gonna set it there. So what we're gonna do now, did I forget to, why is it, oh, I was trying to, whatever, it doesn't matter. I was trying to measure from, what did I say? I forgot. Actually, I just realized that I measure from 1 hertz. I was trying to do, I think I was trying to do 500, but whatever. So what we're gonna do now is we're gonna either play the OCA sweep file from the laptop, or again change the input to your media player and then play the OCA sweep file for the same speaker, and then once you measure it at the same volume, you don't change the volume, you're gonna see how far off you are. If we are close enough, you don't have to mess with it. 1 octave smoothing should be around 75 dB on the left scale here. Okay, so let me change back to Streambox on my receiver, and we measure the front right. So let's do that measurement with the OCA sweep file. I gotta click on from file. It's already loaded up, but if it's not, you know, you gotta load up that wave file. Click on, make sure that you name it. Click on start and click on the file to play it. Now you're gonna see, I'm gonna tell you how you see this. Once you click on it, it will measure the noise floor, and then once you hear a chirp, that's where that number should start moving, this right here. And it's done. Now before it, if you see that number and that little bar start going up before you hear a chirp, that means your microphone heard something. So you need to restart that sweep file and you need to click on cancel and start again. Okay, also if you get an error, you can try to measure again, but as long as you get around 75 hertz, you should be okay. You should not get an error that something was wrong. As you can see, I'm a little bit above, which is fine. To be honest with you, you don't really have to mess with it. I know that the trim levels are all over. Usually the LCR for me is several decibel higher than the rest, so that means my surround speakers will probably measure around 75. We just need to be around here within a couple dB. Okay, so this is at around 77 dB. For me it's fine. I could probably lower it 2 dB or 1 dB. To be honest with you, it's not gonna matter as long as we are around the same place. Okay, also the limits, usually I set it like this. We only gonna EQ above 200 hertz, so the left hertz is set to 150, the right one is 20. Maybe you can even put it to 21, it's fine. The bottom dB is 65 and the top is 90. So this is how we are going to look at the measurements. Okay, now let's close this down, we don't need them, and now we are ready to measure. So we're gonna click on measure. Obviously make sure that that file is loaded up. We're not gonna be able to set the DBFS number here anymore, it's fine. Usually you're gonna measure the center first and then front left, front right, LFE and the rest. Okay, so we're gonna make sure that we name it C flat Dirac if you want, or you can just leave it C flat, and we are going to measure it. As you can see, it beeped, and now that bar starts moving. Obviously when you do these sweeps, you don't want to sit in between the microphone and the speaker, so try to move out of the way. Create a environment how you did the calibration for Dirac. So if you have curtains pulled away, pull them away again, you know, obviously move out of the way. And yeah, just measure all the speakers. I'm not gonna measure it right now, I have already taken measurements. So with some magic, let me pull up my old measurement, not default, flat measurements. There you go. So let me show you, this is how you would end up with. So once you're done with all the measurements, you know, it's gonna look like crazy. As you can see, there is no smoothing applied. But if we apply a smoothing, usually I use full octave or 1 octave smoothing or psychoacoustic, and this is what it looks like. You know, nothing horrible. As you can see, the high frequencies is super close, around 11K, but it's all apart at the higher frequencies there and also around here. As I mentioned, to be honest with you, if you level match the speakers as is, it's already a big change. It already helps a ton, and I will cover that too, how you can actually level match speakers if your trim levels are locked, using that online tool that I will cover soon enough. Okay, but yeah, this is what we have. As you can see, all the speakers down here, psychoacoustic smoothing is applied. To EQ, what we're gonna do is we're gonna switch over to 1 full octave smoothing. So the next step would be to EQ the speakers, but for that we need to create our room curve. Okay, so now we're gonna head over to this website. Okay, so this is the online tool that we are going to use. We got the room correction target curve generator, where we're gonna generate our room curve. I know it's called target curve generator. You could actually generate your own target curves here and just use that. Same difference, room curve, house curve, target curve, it's pretty much all the same. The start hertz on the top left is where the target curve start. The start dB is how high that low end rises. Okay, the low cut hertz is where that rise start, the low cutoff hertz. Then the high cutoff hertz is tied together with the low cutoff dB and the high cutoff dB. Basically, it will dictate how much that region is rising, and the high cutoff hertz is the transition point at the 0 dB line. So wherever you enter there, that's where the target curve will fall below the 0 dB, and obviously the end hertz is where the target curve ends and how much it rolls off. You also have curve types which you can change. For speakers, usually I only use linear or log linear. Then once we're doing a target curve for the subwoofer, we can change the curve type low to cosine. Okay, I think it's simple enough. Obviously you can play around with it a little bit. It's a little bit hard. Let me just put F11 here. There you go. Maybe you can see it a little bit better. Every time you change something, you have to hit generate on the left. First, I usually change this to 20,000 and hit generate. You can't really see it, but it jumped a little bit there, so we are not correcting all the way up to 24,000. The steps per octave, you can leave it at 6. Usually I change it to 3. This one changes how many dots you have here, so changing it to 3 makes it, you know, half as many dots. When we create a target curve for the initial step, the start dB doesn't really matter. We are not correcting under 200 Hertz or so, so this can stay at 0, but if you put it to 0, it's kind of hard to visualize how the curve will look like. So I like to keep it the way how I'm gonna end up with. So put it to whatever you want to boost the bass with. I put 6 dB for the LCR, and then we can change around a couple numbers. Obviously if we change this to -3, that will roll off a little bit less. If we are changing this to 2000, you're gonna see that this point right here where it goes below that dB line, it will jump back towards here. You see, so it rolls off a little bit more. If you hover your mouse over a dot right here, you can see the frequency and how much it cuts or boosts. So you can check there what you're doing, and you can come up with your own curve. I'm also including, I have recreated Harman NAD sound advice or whatever. I recreated a few curves that I will link down below that you can copy, because you can do the same thing and EQ your speakers towards those curves. To be honest with you, what I like to do is my own curve, which usually if I do -3 here, which depending, if you have a bright speaker, that -3 could mean that you are EQing a speaker like 6 or 7 dB. If it's really bright, to get to here you will have to EQ that down 6-7 dB. I'm gonna change this. So if we are doing the -3 dB, I'm changing the high cutoff dB to -0.5, and I'm changing this back to 4000, which was default. So this is the curve that I usually use. I create two different calibration to test what they sound like, what I like. This will be one, and then the other one will be 0.75 and -5. So this will be a little bit more aggressive roll off. You can create your own. You can create whatever. If you don't want to tame the highs too much, you can just use, you know, -1, whatever. Oops, I gotta put 0 there. Sorry. You can do whatever you want. It's completely up to your choice what you want to do. And also, this is a very good way to tame bright speakers. I do have clips speakers. I don't think they are super bright, to be honest with you. I like them as is, but I do roll down the highs 3 or 5 dB. Changing the curve types, let me show you what that looks like. Basically, let me just do this, -5, -0.75. I don't want to spend too much time here, but okay, if you're looking at, let's say, 8000 hertz, we are pulling down the frequency range almost -2 dB, 1.8. If we change this to log linear, that line is not going to roll down nicely, but it's going to be a straight line like that. So now that 8000 is more like 2.6. I know this line right here, what you're looking at, looks crazy, but I can promise you, because of this graph, it looks crazy. If you import this into Dirac Live, it's not gonna look like that. It's gonna be a nice little, you know, curve. It just looks crazy. If I wanna show it to you real quick, I can do that. Okay, so this will be the default curve, and if we load up what we just saved, I gotta go to downloads, and so as you can see, this will be an okay curve to use also. But let's keep going with the guide. Now we are back here. As I said, we are creating a room curve. Let's set this back to linear, 0.75 and -5. Let's just use this. What I usually do is I create a screenshot of this and I save it, just so if I have to ever come back and change something or redo something, I know what room curve I use. To be honest with you, everything is saved in the name. If you want to just, you know, download this, it should be all here. 10.6 means these are 10 and 6, 1000 and 0, 1000 and 0, 4000 -0.75. So it's all here. It's all here. The also the curve names are here too. So linear, everything is there. If you want, you can just download this. You can even name it, the date. Let's say, what is this? August 1. You know, LCR if you want to do this, and then you can make another one with 3 dB if you want to change the bass rise differently for the surrounds. But you could just save this. But what you need to do right now is you need to copy out the numbers from here from 10 to 20,000. We're gonna copy that out, go to the desktop, make a new text document. I usually name it the first and the last number, so 6 minus 5. This is our 6 minus 5 room curve where we have 6 dB base rise and minus 5 dB roll off. Save it, close it, open room EQ wizard, click on the first speaker, click on EQ. Here we're gonna change a couple things. Manufacturer is mini DSP. I know we're not going to use a mini DSP, it's fine. We just make sure that by selecting this we are getting a 96 kilohertz bytecode file. And then target settings, we need to change this. If we EQ in a subwoofer, leave it as subwoofer. For speakers, I set it to none. Okay. Oh, before I forget, here we're gonna apply the same limits so we can see everything from 150 to 20,000. And here you can change the smoothing, which will come in play in a little bit. House curve, we are going to open up that house curve we just created. This is our house curve. We're not gonna have an additional room curve. Nothing is ticked here. We're gonna come back to this, but filter task, we have to change this to from 200 to 20,000. To be honest with you, if you're using regular Dirac Live, you can lower this a little bit to like 100 hertz. As long as you stay above the crossover frequency, you are okay. For Dirac ART, you have to stay above 200, but it's completely okay if you just leave it at 200 for every version of Dirac, okay? And then you can copy these numbers, 3, 1, and actually I'm gonna do 0 here, overall max boost. Actually, I'm sorry, this is the setting that we're gonna go with. Individual max boost is 0, overall max boost 0, flatness target 1, and we're gonna allow high shelf from -6 to 0 dB. Okay, now once we've done that, we're not gonna adjust anything left to right, whatever. We're just gonna apply these limit settings, and then we're gonna click target. We're gonna click on calculate target level from response. You see that number jumps, should jump really close to the 500 hertz region towards your measured response. And then we're gonna click on EQ, but very important is that our smoothing is set to 1/1. I will show 1 octave. I'll show you why. So now we're gonna click match response to target. You're gonna get a little warning here, which is fine, don't worry about it. We're gonna EQ towards it. It just created 3 wide broad EQ filters. If you click on EQ filters here, you can see what it did. Actually done 2 PEQs and 1 shelf, high shelf, okay, which is completely fine. If you see the speaker response going below the target, it's fine. You don't have to mess with it. To the final adjustments, we will get back at the very end, but usually what I like to do is I like to click on psychoacoustic smoothing and just check on things, and it looks perfect. As you can see, we did not change the overall response of individual peaks and dips. They look the same, but they are curved down. Whatever you see there is just reshaped to follow that. Now if we would do something crazy, if we would do something like this and EQ it with psychoacoustic, now we would make it flat, and this is why we are not doing it. You see that response look really different. I mean, somewhat similar here and there, but that is more of a ruler flat response that we are not trying to do. So what we are doing here is completely fine. If you messed with this, 2 things you can do. First, because of the low shelf filter, high shelf filter sometimes doesn't clear if you match the response again. I will go back to EQ filters and delete the whole thing. Then I will adjust this back to 1 octave smoothing and match response again. Now you can scroll down, you can generate measurement from predicted, which will put an additional measurement here that you can check on. You can just click that, but what you need to do actually is we're gonna click on Save Filter Coefficients to File. You're gonna pick a folder and you're gonna name this FLEQ because this is the left speaker, as you can see, and you can save it. You can just, let me just save it right now. And yeah, you can just keep going for every speaker. Okay, it's very simple. And then once you have every speaker done, obviously you're gonna have more EQ filters here if you generated the predicted. But as you can see, if I change this to psychoacoustic and then right click anywhere here and clear selections, I'm gonna scroll up to the left and to the EQ left. This is the before, the yellow, and the blue is the after. So let's see what you can do if you have a speaker system where it's naturally rolling off. Okay, I'm just gonna pull up these measurements. It doesn't really matter if these are measured after Dirac or not. What I'm trying to show you is what happens when they naturally roll off. So if we actually go to actions and create a dB average, let's click on the dB average and set it to 1 octave smoothing. As you can see that if I click right here around the 500 Hertz region, you can see that actually it rolls off above like 2000 Hertz. So we want to recreate this basically in the room EQ generator, okay, the target curve generator. So what we will do is, as I said, we can actually do is click on dB average, click on EQ, make sure that this is set to none, make sure there's no house curve applied whatsoever, and then click calculate target level from response, generate measurement from target shape, and that is our target shape for the dB average. And now we can make notes what roll off is happening. So by looking at this, I would say that there is two things happening. There's a slight roll off probably until like 10K, and then it has a bigger roll off above 10K. So we can create something like this in the generator. So we would go back here, we would adjust some numbers. In this case, I would change this to 10K because we want that smooth roll off change to a bigger roll off at 10K. And we can also look at the numbers. So if we put our mouse, hold the left button and move it to that yellow line, you see at 77.28. Now we move it here and we measure, what is it, dB and a half if I'm correct, and then we can take it to 20,000, and that will be another 3 dB, yeah, another 3 dB, sorry. So we will create here, we will put 0, we need to make sure that this is 1000, low cut of dB 0 because we are not adjusting this region between 200 and 1000, and then leave that at -1.5, and then this one at 3. Now we're gonna click on generate, and something is out of order. What's out of order? Low cutoff. Oops, that's 1000. I'm sorry. You have to make sure that everything is correct. The numbers cannot be the same. Click generate, and this is what we have. I don't care about the start dB right now, to be honest with you, because we're not gonna mess with that, but we can, it's okay, we can do 6 right here. Now we can do the same thing again, measure, copy everything out. I'm just gonna reuse this file, don't worry about the naming right now. You can rename it whatever you want, you know, whatever, it doesn't matter. Now we're gonna go back to the dB average and EQ and scroll up and open up that file as a house curve. As you can see, we are not curving enough. 70, more or less 77, around a dB and a half. It should be more about 5 dB. I'm sorry, my bad. miscalculated something. I calculated below 10K, which it doesn't work like that. I have to calculate from the original line, which was 77. Let's open this again, paste it, save it, and let's open it again. Yeah, now it's a little bit too much, so it's probably 4.5 or so, but to be honest with you, this is fine. You don't have to get it super perfect. This is already fine. Now if you want it and you want a little bit more roll off, you can do that too. Let me just show you something here. Let's open this up again. As I said, this was okay, and now we're gonna generate measurement from target shape, and we're gonna enable all measurements. Now we're gonna turn off the flat one, and this is our target. Okay, as you can see, some of the measurements are a little bit below that, some of them are not. You can leave it like this and just, you know, EQ towards this one. We're not boosting anything up, or if you want to make sure that everything is following closer, you can reduce this just a little bit. You don't really have to, but you can mess with it. If you hit everything and select 1/1 smoothing, as you can see, yeah, some of the speakers are going to be below, but that's fine. What we are trying to achieve here is that some of the speakers that's not really close to it, it will be close to it. Like the front right is way above, the center is way above, the left is way above, and the rest is more or less the same. So let me just quickly EQ everything towards here and show you what we get at the end. So we need to make sure that the target type is none. If you don't see the target curve, and even if you click on the calculate target level to response, you have to change the target type to none. Make sure that every speaker is at 1 octave smoothing. You can also just come back here and make sure you set it to 1 octave smoothing. And let's do the center, speaker target type none, house curve applied, calculate target curve. These are the same, and match response, warning, ignore it. That's it. And then generate measurement from predicted. Obviously save the filter coefficients to a file, and we're just gonna keep going. I'm not gonna talk no more. I'm gonna speed this up so it's faster. So this is a speaker that was around the target curve to begin with, but as you can see, there are parts of there are regions where it's a little bit too high. So let's see what it looks like once we EQ it. It did create 2 PQs, and if you go back to psychoacoustic, you can see it is a little bit closer to the target, so that's good. We can just keep going. And that will conclude our average dB target curve EQing. And now this is just predicted. We also need to level match. That will bring it closer together, okay? But this is the before and this is after. I know it doesn't look that much different. I mean, you can see that some of the stuff is a lot closer. As you can see up there, it's a lot closer. Okay, some of these are a lot closer. Now what you're gonna do is you're gonna come back to this page. Now we are going to do the second pass of the room curve. We don't want to double the high frequency roll off. We are only gonna focus on that base rise for now. So you need to change all these numbers to 0. The right numbers, the 3 right numbers needs to be on 0. You're gonna click on generate, and you're gonna click anywhere here in this little window, and you're gonna select all and copy. Then you're gonna go to the other website, which you can also right click here and open a new window. Make sure that you never click away from this, try to keep it. If you have done a screenshot and saved it, or if you save the name, you can come back and just redo everything. It only gonna get hard if you really change around too many numbers here. You can mess around with that on your own time and just change this, and you know, to 2000, 8000, whatever. You can mess with that on your own time. I don't want to like really confuse you, but once we copied everything out from the generator, we're gonna come here, click on the top window and paste it in here. Now if you click on generate target curve, we will get the same curve what we see here, but what we need to do is we need to open up that EQ file that we just saved and copy out the bytecode files. These are the bytecode files here, and we're gonna paste it into the middle window. Now what we're gonna do is we're gonna convert these two things into a usable target curve. So if I click on generate target curve, this is our target curve that we can save and what we can use in Dirac. So I will save this FL custom EQ. We can download it, and you know, obviously we will have all the speakers in that custom folder. What we create, we will create a new folder. So we will name this custom EQ. Obviously save everything into that folder. Open up each file. Pay attention what you open. Holy moly, it takes forever to copy a small text file. Open up every speaker. Make sure you pay attention to the name and what you paste here. If you are creating a different bass rise for the surround and for the Atmos speakers, obviously when you change it here, save this. You could change it to surround here and then download that, or take a screenshot. Actually first you need to generate, then download it. I just saved it again, the old one anyway. You would copy again and just stick it up here and stick the surround left here, and then generate. And you would, if I just do this right now, obviously it would only change this. So the reason why we're doing this two-step, because first we only focusing on the high frequencies which we EQ towards to each individual speakers, and then we do it again for this, okay, for the bass region. So now we will go back to Dirac and you can load up everything. Then we can go back to Dirac, open up our last project. It could be even the flat that we saved if you saved it, and we're just gonna load up all the target curves. We're gonna take each speaker if we can, and we're gonna ungroup them into their own individual group. If you can do that, it's fine. I'm about to show you what to do in that case. Okay, so let's go back here. So this is group 1. We're gonna click on front right, hold, and pull it outside the group, and then just drop it. Now you see you have front, left, and right, and front, left, center, and right. We will do the same thing for every single speaker. Then you can right click, load target curve, and we will load our own custom target curve. We will go into the folders. As you can see, these are my EQ, and the target curves are saved separately. So we will find our front left and we will load it up. As you can see on that image, if you were sharp-eyed, I had a couple different versions for each speaker. It's fine. I'm gonna explain what I did there at the very end. So we will load up the center, and you just keep going to every speaker. And as you can see, let me just load up another one so I don't have to do this. So once you load it up, all the target curves for every speaker, you're gonna see that each target curve looks different. They all have different shape. Nothing crazy, but they do all have different shape. This is front left, center, right, surround left, surround right, height. So yeah, as you can see, each and every one of them has some type of different roll off, because that will achieve that they will measure and sound alike. Because if one speaker sounds 4 dB higher above 10 kilohertz, it will sound a little bit different, or a 5 kilohertz, or whatever the case may be. Also, sometimes Dirac sometimes does this where it shoots up above 20K. Even with the regular slider, it does this. The regular slider only goes down to minus 3 dB, but as you can see, it doesn't really do it. That's it for Dirac Live. Now we can talk about what happens when your speakers are grouped together, like the surround left and right, front left and right, and all the other ones. Okay, so obviously if you have that, what you need to do is you need to go back to Room EQ Wizard, and you're gonna right click anywhere down here, you're gonna hit clear, then you're gonna select your speaker pair. These are the two speakers. Okay, now you're gonna click on actions, and you're gonna click dB average. Once you've done that, you have to click on this on the left, dB average, set graph, 1 octave smoothing, and now we can EQ this. So the same thing, we're gonna go back to EQ, which is, yes, it is, okay. And then, yeah, dB average, there you go. And then we are keeping everything the same as before. We just need to, every time you need to click on calculate target level from response. As I said, usually it needs to jump, the target level needs to jump where the 500 Hertz region is on our measurement response, and then match response to target. You're gonna get the warning, but ignore it, and then that's it. If you want just to check on it, click on psychoacoustic, and it happens sometimes that you can leave it like that for now, but this happens sometimes, which I will cover later, that it makes some region of the response go below the target. I will cover this, how to adjust this a little bit. You don't want to adjust it too much, but you can mess with it a little bit. I show you at the very end. You will save the filter coefficient and custom EQ, and we will save this. Usually what I do is we will save it as front left, front right together. Save it, go back to your room curve generator, make sure that you have the correct start dB, and the rest is all zeroed out. Copy this out just like before, put it here. We're gonna open up our FLFR EQ file. We're gonna copy out the backwards and go back here and enter it into paste it into the middle window. Generate target curve. Obviously we need to name this FLFR custom EQ target curve, download, and then you import it into Dirac, and this will be our custom curve. As you can see, it does look different than generic target curve that you can import. So yeah, you can do the same for all the other speakers, and that will conclude what to do when your speaker pairs are locked together. Now that I have explained what to do when the speaker pairs are locked together, now let's talk about level adjustments. So your levels are either adjustable post calibration, or they might be locked. Whatever the case may be, I'm gonna have a video link down below. You have to download the original file from the Google Drive, what you can play, and you're gonna use Room EQ Wizard. You're gonna click on SPL meter, have it at C weighting, very important, and slow. You're gonna play the video file, and you're gonna mark down every single SPL you get for every speaker. Okay, so the video will look like this. Let me just show you real quick. This is the video that I got created by this gentleman on ABS forum. The reason this was done is because I have checked all available test noise videos that I have found, and they were not perfect. The surround and Atmos speakers and the LFE was always off by several dB. I even paid for some of these test tones. I did not get the Monsul or whatever that is. I forget the name, what that is. That's supposed to be good. I didn't check it. This is a free version that you can get, and this is all you need. So you will need to change the volume, which is going to be 10 dB below whatever you have right now, okay? Because what we adjusted the level to before was minus 30 dB FS or reference level, which will be 0 dB, and this is a minus 20 dB FS test noise, which will be basically 10 dB higher in volume. So you need to adjust the volume, the main volume on your receiver, lower by 10 dB. If you have the other volume type, depending if you use relative or absolute, you're gonna set it to 70 dB for Denon, Marantz and Yamaha, or 72 dB for Onkyo, Integra or Pioneer. If you have a different processor which doesn't use this type of scale, and you know it might be already loud at 20 dB or something, whatever you set it to, try to set it low, 10 dB, 10 click lower. It might be too low, but what you need to do is basically just you need to adjust each speaker to each other. So you just need to get the level until you measure one speaker at 75 dB, and then measure all of it together, and then just write down how far apart each other, okay? If you have to play this through your laptop in VLC, what you might need to do is you need to go to Tools, Preferences, you need to go to Audio, and you need to select the HDMI audio pass-through to enabled, okay? Hopefully you don't have to run this through your TV. If you do, you also need to change the PCM to bitstream or audio pass-through. But just always make sure that when you play this, the right speaker plays the right noise. If you don't have front wides, if you don't have top middle, obviously don't worry about when noise is playing out from those speakers, so skip those, okay? Each speaker plays for 1 minute, and then it moves to the next one. If your trim levels are adjustable, I usually adjust the subwoofer to minus 7 dB, below minus 5, that's for sure, and then compensate for the difference via target curve. Hopefully you watched my other video where I explained how to get a negative number for the subwoofer, which sometimes might not happen no matter what with some weird processors like the Arcam and whatnot. It might, don't matter where you put the subwoofer gain, it might not give you a negative level. It is what it is. But anyway, whatever you see here is what I have on the TV. As you see, the front left was a dB and a half too high. So you will measure every speaker, okay, and then write it down on a piece of paper or pull up notes on your phone. Write down everything. Then you're gonna go into your trim levels, if you can adjust it post calibration, and you're gonna adjust everything by as much as what offset you need. So if the front left was a dB and a half too high, hopefully and most probably your right is gonna be just as high. You're gonna click 3 times down on the remote to lower the trim levels a dB and a half. If the center is 3 dB high, then you're gonna click it 6 times towards down, and you're gonna lower it by 3 dB, and you're gonna do everything. You're gonna come back to the same video and you're gonna check the levels again. If everything measures at the same level, you're good, okay? You're done. Now, if you have your trim levels locked, the next step would be to adjust the trim levels via target curves. So this is where the 2-step room curve process comes into play. This is why I do it this way. I used to do it a little bit differently. Anyway, I don't want to confuse you. If you need to adjust anything, any SPL, all you gotta do is you're gonna come back here, you're gonna leave the start dB as wherever you created the base rise. So if it was 6 dB, then leave it at 6 dB, and then lower everything else by as much as you need. So if you need to lower the front left by -1.5, you're gonna hit -1.5, not 15, -1.5, and you're gonna enter that to the low cut, high cut, and NDB. And if I click on generate, you can see that everything down here will jump down and everything here stays the same. Hit generate. As you can see, everything is jumped down here. It changed a little bit below between 100 and 160 hertz. So for that, what I usually do is I bump this up to like 1100 and it will jump back where it was before. Okay, so now you're gonna copy this out, and then let's say I enter the front left here, but I can show you again, whatever. You're gonna paste it up top, okay? And I'm just gonna generate it, and you're gonna see that everything will jump down above 160 hertz. I know this is not the front left speaker, but just to show you what it does. There you go. You see everything just jumped down a dB and a half, but obviously if I was messing with the front left, I would need to open up the front left and paste it on the middle window. And then generate. And I know you can't really see it right now, but obviously this region before was laying on top of the 0 dB. But this one is lower now. I'm gonna show you a picture of what it looks like once you import it into Dirac. What's the difference between the two? 0 dB and -1.5 dB. If your speaker groups are locked, obviously you measure both of them and you find a middle ground between the two. Hopefully speaker pairs are measuring like half a dB apart only, but even if they are 1 dB apart, just pick a middle ground. It is a process. You better off writing down everything because you're gonna lose track of what you're doing, okay? And obviously then you're gonna export everything, save the target curves, name it. So if this was an actual calibration I do FL custom EQ -1.5 dB. This is how I would save it. You can even have, I mean, obviously you know that the LCR you do whatever base rise, but if you want you can do 6 to -1.5 dB, so you know that the 6 dB was for the base rise, okay? If you want to save it this way, and then just import everything into Dirac, and that will be all. That's how simple it is to adjust the SPL for each speaker. And if you're thinking, well, this must cause issues with art and whatnot, not really, because as I said, we only EQ above 200 hertz, so we are leaving everything untouched, where Dirac does its own Dirac ART does its own thing, which is actually up to 150, not 200. And also when we do this SPL adjustments, as you could see it on the image what I showed you before, we are actually not adjusting anything under 200 hertz. We're leaving everything. But even if we have changed everything, we are doing a 3 dB rise or 6 dB rise will change more than what we are doing here for art. But it doesn't matter because Dirac will recalculate the filters once you apply a target curve. So it's not gonna cause any issue. It's actually causing less of an issue than you adjusting the trim level if it was unlocked. So yeah, you can do this instead, and hopefully this is helpful for you. Oh, before we go further, I also want to explain what you can do with a existing target curve. You can adjust, if you want to adjust an existing target curve, as I said, you can recreate a target curve by copying one of these things, but I also uploaded a file that you can download, and it has the curves already made for you guys. Let me just make sure that I have that. Let me go here. There you go. Let me just download this So I have recreated the audio device, the NAD, Storm Audio, LCR, and Surround. I did not recreate the Harman. I mean, pretty much it's basic. It's just bass rise and cut at the high end. You can do whatever type of curve you want. These are, I just recreate these so you guys can mess with it a little bit, but let's look at NAD curve, and then we can apply it in here. Actually, I'm sorry, hit flat. So I recreated these as bytecode files. So you're gonna enter those on the middle in the middle window, and on the top window you're gonna select flat. And now if you click on generate, this is what I have recreated. It looks a little bit different than what I use, but so you can adjust this if you don't want to do any EQing, all you're doing is just level adjustments. You can also do that. What you can do is you can leave the start dB at 0, and whatever you need to adjust for the others, hit generate. Then you're gonna copy this out, go back here, and you're gonna paste it to the top. And if we hit generate, you can see it's lowered above 200 Hertz. It's the same. I know the graph makes it look a little bit weird sometimes, but that's all there is to it. Now you can do the same thing. Actually, you can do the same thing with Magic Bean files. So if you want to level adjust with Magic Beans, what you need to do is you're going to open up Magic Beans, you're going to open up your latest project, and then you're going to export it for mini DSP, not for Dirac, for mini DSP, because we need Magic Beans to create bytecode files, which we will enter into the middle window. So mini DSP 2x4 HD full is what we need, and we're gonna export it. If you use per channel, you select that. If you use unified, just whatever you usually use, that's what you select, and we're gonna export it, and we're gonna put it desktop, custom EQ. Okay, once we are done with this, you can close Magic Beans. You're gonna open up the custom EQ, and every single speaker has an input and an output text. What you need to do is you need to open up the output text file, and you're gonna see the bytecode files. We only need, well, this one doesn't have bytecode files with zeros, but what we need to do is we need to take this, we need to copy it and stick the entire thing right behind the bottom of the input text. So now we just pasted everything in here, but you need to make sure that the bytecode files is continuing after 10. So it needs to be renamed 11, and then 12, and then 13, 14, 15, and 16. If you have all the way up to 20, then rename everything. Now you can copy this, and if I don't want to save it, I don't care right now, but we go back here and we're gonna stick it into the middle window, and let's click flat again just to show you what the default Magic Bean curve looks like. So this is the Magic Bean curve, and we can lower this the same way like before. So if you need to lower it by 1.5, you know, then just take that, put it to the top, paste it to the top, oops, click on generate, and that's it. We just lowered everything by 1.5 dB. Now you can do this to all the speakers. Let's quickly look at some of the fine adjustments you can do in Room EQ Wizard if you really want to make it. Obviously, this is why it's good if you save everything, you name everything correctly, so when you have to mess with it, you can go back and adjust things and use the same curves for the first and second pass, whatever. But let me just look up. What I want to do here is let me pull up an older EQ. So I remember, if I go back to, I think, surround right, I think, where is the surround left? So let's switch back to psychoacoustic. Make sure that everything is set correctly. The allow high shelf is on and the numbers are correct. But as you can see, now that we switch back to psychoacoustic, there is a region here which is a little bit too low, and there is a region here which is too high. You can definitely adjust it a little bit, and the way how I usually do it is you could take that last measurement. In this case we have two PQs and a high shelf. I take that high shelf, I click on it, I can pull it up, I can pull it down, I can pull it left, I can pull it right, and basically I just adjust it in a way that I still keep the same shape as this, but having that last couple dips and peaks centered around the target. But now, as you can see, I have something here that's way too high. So I'm gonna pull this PEQ back here. This is a white PEQ with a Q factor of 1.5 or so, and I'm gonna create one more here to the center where this is, so it goes from 4.3 to 11. So I'm gonna probably put another PEQ here and pull it down with a low Q factor. So I'm gonna click on another spot here. I'm gonna select PQ. I'm gonna adjust it to 6300. I'm gonna adjust like a 1.5 or that Q factor, which is the bottom number here. That dictates how wide is a filter. And then I don't even have to really do anything there for pulling it down. What I'm gonna do is I'm gonna come back, I'm gonna set it back to one octave smoothing, and I'm gonna click on optimize gains, and it just pulled it down for us for the perfect amount. If we go back, it's done. And that's it, and we just adjusted it a little bit, and that's all you need to do if you want to further mess with it. Okay, you don't really have to do this. If you want to play around with it, test it out, you know, save it as a second or third calibration, and yeah, that's it. You know, if we're looking at this one, is the same thing. So we have this is a surround right. You know, we can pull this down. This one already has a few things here that we can use. We can, I would say, look at the last couple dips and peaks, adjust it to the middle, and then you can just pull this a little bit higher, and then that's it. You can save this and measure it. I go back to the left, I click on EQ. You can just, you know, make this a little bit higher. If you remeasure it and now it measures too high, about 15K, it's fine. You can add another high shelf and just take that. This is that. No, that's not it. Okay, put it to 15,000. That is our new high shelf, and you just pull it down a little bit and add the secondary high shelf and readjust it. You can export this, measure again, and readjust it. You're not really looking for perfection, to be honest with you. Even without this, you should be okay. But this is something that you can experiment with. You know, I'm not saying that you need to do this. You can, you know, nobody's stopping you. You can experiment with it as much as you want. Obviously, you wouldn't need to save the backward file and then go back to the generator, you know, recreate everything you needed. If you're already adjusted the SPL and you wrote it down that you had to adjust the, what speaker was the front left? If you already had to adjust the speaker to -1.5, you need to do all that here. Okay, so don't forget that. You always need to pay attention that what target to what room curve to use at what time. At the end, when you want to do something final, you also need to recreate how you saved and converted the last PEQ room curve into a target curve. Make sense? And last thing before I let you guys go, it's very, very important. If you guys are actually want to do some testing and listen to one calibration compared to another, it's one of the most important thing to actually level match everything. If you check in one calibration where the speakers are all over and the main speakers are a couple dB higher, while the custom calibration you level meshed everything. Let's say you're comparing storm audio to a level meshed custom EQ target curves, then it's not fair, because immediately as soon as you hear the front, the main sound stage being more dynamic because it's louder, you will automatically say, oh, this is better. So if you can't level match everything, it's not gonna be a fair comparison. Okay, you need to level match everything, but I have already covered how to do that. Even if you want to compare just regular storm audio, you can import the backward files, lower it, raise it, whatever. Obviously you have to measure everything post direct calibration, so you have already imported all the storm audio to every single speaker, export it to a slot, measure the speakers, write it down, and create custom adjustments. I have the storm audio backward file in the zip file, so you can just use that and adjust the level for everything. Okay, unless if you have the trim levels unlocked, you can just do it easily. Just when you do the level adjustments, ignore what you measure while the internal test tones are going. You can't use the internal test tones once you have done a calibration done. Okay, so I hope this was helpful. If you have any comments or you have any questions, you can leave it down below. As I said, if I forgot anything, I will try to put it either on the screen while I'm editing this, or there will be a section down in the description where I will put different stuff that I forgot to say, or if I made an error and I said something wrong, I will put it in there. So check on that once in a while, and I will appreciate if you guys give it a thumb up, and if you subscribe. Let's grow this channel. I hope that I can make other videos for you guys that will equally helpful. Thank you for listening, and see you in the next one.